A very warm greetings to everyone watching this video, my dear friends, teachers, and the judges judging this project. Today I, Ayush Gupta, with my partner Vaibhav Arya, doing the project named as Mr ThermoParcel, temperature-based container, under the mentorship of Mrs. Hayat Fatima Ma'am. Index of the project goes like this. Why this project is necessary, the idea of the project, the aim of the project, the target audience of the project, components, and the structure of the project is basically explained in this PPT explanation. Why temperature control container is desired in today's post-pandemic world. Includes needs of the project. First need is required for storing vaccines. After the pandemic, the vaccines were launched, and the main issue for using the vaccines was the storage and temperature maintenance. As the temperature differs in different countries, this led to waste of vaccines at a very high level. And for storing the vaccines, countries have to pay a very expensive cost for the storage. The second need of this project is sample storing in medical labs. The samples in the medical labs are required to be stored at a fixed or desired temperature, which is very tough to maintain, but there are some solutions for this issue also. Many refrigerators and heating thermal containers are invented for storage, but they have drawbacks as they can only provide hot surrounding temperature or cold surrounding temperature. That is, they are not adjustable according to the situations or the temperature around them. The basic information of our project. Our idea originates from a real problem that we faced in our academic research. The safe exchange of temperature sensitive biological samples with collaborators. For example, Viola works on the malaria disease and there is often the need to send or receive blood samples. However, if the samples are not kept at a correct temperature during storage and transportation, they can easily degrade and become useless. This is all more frustrating when samples contain precious types of blood that have a special response to malaria and come from rare patients. Genesis of the project. The common method to send blood samples of this type is to completely freeze them before shipping. Use a standard courier for frozen goods and then carefully defrost them after delivery. Apart from still being expensive, such a system is far from ideal since freezing defrosting always alters or damages the parts of the samples, and the defrosting process itself follows a specific protocol that requires additional chemicals. Furthermore, items often get delivered to university at a campus parcel depot where inappropriate storage conditions and delivery notification delays are frequent causes of sample degradation. Aim of the project. The aim is to develop a temperature control container that can be used to safely transport sensitive samples with a conventional mail service. Our prototype device called Mr ThermoParcel works within the range of temperature 4 to 37 degrees Celsius and can powered by either a mains adapter, internal battery or other 12-watt sources such as car, secret lighter or laptop charger. The main features of this project: balanced temperature, low power consumption, easy working of project. We integrated a temperature control system in a conventional polystyrene container of a size of small parcel used from a delivery of chemicals. We optimized and tested it with blood samples, but the same system could be used for a vast range of other biological materials such as cells, culture media, temperature sensitive chemicals, emulsions, and enzymes, or even adapted for solid items. The concept of the system is shown in the figure 1. Cooling is achieved with the Peltier module, with the cold side attached to a small sample box inside the polystyrene container, and the hot side connected to an external heat sink. Heating is formed with the heater mat placed inside the sample box. Temperature is constantly monitored using a sensor in contact with the samples, and the heating cooling intensity is regulated by an Arduino controller. Future of the project. In its current development stage, our device cannot be shipped, mainly because of the size and moving parts of the CPU cooler and the robustness of the construction. However, once the heatsink is replaced by a passive cooling system and a 95K PA secondary packaging is employed, Mr. ThermoParcel could be put in an appropriate rigid container for safe transportation, fulfilling all the requirements of standard couriers for shipping samples by plane and all other transport means. With core aim of the achieved, Other components could be added to extend the functionality of this device. The temperature profile during transportation could be stored in a local memory for later verification or sent directly to the user via SMS at regular intervals. With this all the information, I conclude this project named as Mr ThermoParcel. I hope you liked the project and understood it properly. Thank you.